Managing secrets is hard, time-consuming, costly, and risky. So we're going to talk about that today. We're also going to talk about how to make it less of a pain and less risky. My goal by the end of this session is to provide each of you at least one actionable step you can take to get more dynamic with secrets management in your organization. News stories about breaches caused by secret leaks seem to be the norm now, and there's good reason for concern. Just this past year, we've seen some of the biggest, most damaging data breaches in recent history. I'm sure you've read all about them in the headlines. The average cost of breaches this past year is $4.9 million. Most of these breaches start with stolen credentials, and they involve a human element. So credentials and secrets are not being securely handled, and there's always a bad actor waiting to take advantage of that. On top of all the scary breach stories due to unsecured credentials, why aren't organizations solving this problem? Well, because it's hard, and it costs a lot of time and money to do it properly. Updating secrets or credentials often takes many days, sometimes up to a week of manual ticketed workflows. And there's a real cost associated with this work. What you see here is a quick look at a really simple equation to help illustrate the operational costs of manually rotating a relatively small number of secrets once a month. When you're operating at a scale of tens of thousands, hundreds of thousands, even 1 million secrets, manually updating secrets just doesn't get done due to the overwhelming time and cost to do so. If we look at all the different types of secrets organizations use, they fall into 4 main categories. At the top of this funnel, we see unsecured, static secrets which cause problems, and they're everywhere. They're key value pairs, such as username and password, and they're used to access some kind of system. They're the most common type of secrets organizations use to secure access to applications, sensitive data, or machines. Static secrets are typically not rotated very often because of the operational overhead of doing so. If they're not securely stored and centrally managed, then they are unmanaged and become a liability for downtime or even breach. The longer a credential lives on and the more people that have access to it, the more likely the secret could be exposed and cause a breach. Next, we have securely stored or vaulted static secrets. Properly storing and securing these secrets is a good first step. Ideally, you're centrally storing and managing them in a dedicated secrets management tool that encrypts the secret and requires identity-based authorization for access. These secrets should then be changed on a regular basis, either through regular automated rotation or dynamic auto-generation and revocation when needed. The main reason teams don't do this is because they don't have the systems in place to automatically rotate or generate secrets. When secrets rotation is a manual burden, then we know they often don't get rotated until a breach occurs. The last 2 categories are auto-rotated and dynamic secrets, which are far more secure. Let's talk about what they are and when to use them. Auto-rotated and dynamic secrets are different strategies for accomplishing the same goal, and that is automating the management of a secret in order to reduce the amount of time it could be used if obtained by a bad actor. Sometimes these 2 concepts get confused or conflated, and you might see phrases such as auto-rotating dynamic secrets. While they share the same goal, their workflows for managing secret life cycles are different. Learning about the differences between them help to better understand when and where to use them. Let's look at auto-rotated secrets first. Automating the rotation of secrets enables organizations to improve their security stance by ensuring their static secrets aren't long-lived. Auto-rotated secrets can also be shared by multiple instances of an application or a workload. When a secret rotation occurs, one or sometimes multiple new versions are stored as the latest version for the secret. At the same time, an older version of the secret becomes inactive. When an instance of an application starts up, it will pull the latest version of the secret. The secret's shared between other instances that have accessed the latest version during the same rotation window. It's important to note that if the secret becomes invalid, it affects many instances of applications using that secret. This type of secret is created and rotated on a schedule that you pre-configure. Also, in most cases, the account name or ID typically remains the same, so only the secret is rotated. Pre-creating and sharing secrets allows for low latency and less error-prone secret retrieval. Dynamic secrets are different in that they help you manage intentions instead of managing secrets or credentials. For example, a web server needs secure database access to grab the latest data, so a dynamic secret is generated to support that need. This type of secret is created just in time by an issuing service when the secret management system or application requests one. The just-in-time nature of these credentials adds security benefits which auto-rotating secrets don't have. They are isolated to a single user or single app instance and can have a shorter time to live. So every instance of an application or service gets a different credential with its own time to live. This unique credential is returned to the requester along with a unique identifier that it can use to be audited, located, or revoked early if that functionality is supported. By enforcing a maximum time to live, secrets are being automatically revoked, so a completely new secret gets created at the next request of the user or app instance. This is where some confusion exists when dynamic secrets are referred to as auto-rotating dynamic secrets versus simply auto-rotating secrets. But as you can see, the mechanisms and workflows of the two different types of secrets are not the same. Now that we're clear on the differences between auto-rotating and dynamic secrets, let's take a look at which use cases work best for each. Auto-rotating secrets work well for long-lasting workloads requiring stability and connection, like an application needing consistent access to a database. They're good for applications where frequent restarts are not ideal, for example, where multiple services or clients are accessing them. They also work well to support specific schedule rotation cycles, for example, to meet compliance requirements, such as PCI DSS, where secrets should be rotated every 90 days. Dynamic secrets are best suited for time-bound workloads like batch jobs accessing a database or CI/CD executions. In other words, they're best for workloads where there's a clear beginning and end. They're also useful in environments with stringent security requirements, such as cloud environments, or distributed systems or microservices, where transactions are short-lived or transient. For example, a developer might need temporary access to troubleshoot a faulty system. This has been a fairly quick introduction to auto-rotating and dynamic secrets, but I hope you learned something actionable that you can take back to your organization to address the risk of unmanaged secrets. Thanks for watching.